Hello and welcome. In this video, I just walk you through the concept of phases with respect to Python version of UVM. Here, what we'll try to see a comparison of the phases with respect to Python version of UVM and system Verilog version of UVM. So, if you want the complete information about phases, what phases are all is all about, and the detailed analysis of all phases, then you can go through the video which already I have recorded for system Verilog version of UVM phases concept with respect to system Verilog version of UVM. So I will put the link of that video in the description. So please go through that if you want a detailed analysis of phases. Okay, here just we will try to see the comparison of phases, how the phases are implemented in the Python version of UVM and in system Verilog version of UVM. So let me show you that difference by simple code. Okay. So here this is a system Verilog version of UVM phases. Okay. So let me show you. Here we have to include UVM macros.svh and then import UVM package. So this macros will give us the access of all UVM macros, and this package will give us the all UVM classes. Now here this is a simple component class which is extending from UVM component. Okay, and just a factory registration macro as it is a component. So tick UVM component it is, and this is a class name in the parenthesis. And as it is a component class in the UVM base class hierarchy, its default constructor expecting two arguments. So this is a name and the parent UVM component parent, and in which I am just declaring all phases, just a syntax of all phases, and just an info message to notify which phase is this. Now this is a build phase. Okay, so virtual function void build phase within parenthesis UVM phase is space phase, and end function build phase super dot build phase we are calling a parent build phase, and just tick UVM info. Get type name will give us the class name, that is a sample component here, and just a message this is a build phase and this is what the verbosity UVM. Remember, in system Verilog version of UVM, all phases are function based phases except a run phase. So the run phase is the task over here. Similarly, in case of Python version of UVM, all the phases are function based phases, and that run phase is similar to that a task based. So in Python we are defining it with the help of a keyword called async. Okay, I will show you that. Just remember this point. Now this is what the connect phase, virtual function void connect phase, in parenthesis UVM phase space phase super dot connect phase, and just info message to print this is a connect. Then the next phase is end of elaboration phase. The same thing, we are declaring virtual function void end of elaboration phase and just printing a message this is end of elaboration phase. And the next phase is start of simulation phase. Here also the same thing. Next phase is run phase. Okay, as I told you that the run phase is a task based phase. Okay, so as you can see, virtual task run phase, and here just we are raising an objection and dropping an objection, and just we are printing a message that this is a run phase. The next phase is an extract phase. So the same thing, virtual function void extract phase, in parenthesis UVM phase space phase, and just printing a message. Similarly for check phase and the report phase and for the final phase, and just we are ending a class sample component. So what we did, we defined we wrote one class called sample component which is extending from UVM component, registered with with UVM component details factory registration macro, then defined default constructor, and we have defined all the phases. We start from build phase to the final phase, and just we are ending a component called sample component end class. And the next top level component, we are defining a test class, sample test class, which is extending from UVM test, as it is also a component class in the UVM based class hierarchy. We are registering with tick UVM component utils factory registration macro, and its default constructor also expecting 2 arguments. And just here we are declaring a sample component, this class, okay, the handle of that class CMP. And in the build phase we are creating that, okay, so you can see build phase we are creating using factories create method. This is the instance CMP is equal to class name sample component and colon type ID, and create we are using a create method, factories create method. While in case of Python version of UVM, no need to give this colon type ID colon. Just dot create method is enough. I will show you that in that code. And here we are just ending a class sample test. In the top module, which is used to invoke this class, in that I am just declaring initial begin block and just one method run test, and just giving a test name. So this run test is a task which initiate all the phases to start from build phase to the final phase. Okay. And just ending a module top end module. So this is what a simple class, okay, which consists of all the phases. Just we are declaring a phases. We are not doing anything. Just we are printing a message with the help of those phases. Now let me show you how we declared all the phases in case of Python version of UVM. So if you see this code over here, here we have to import pyuvm, and from pyuvm import star. It is equivalent to import UVM package colon start, as we saw in system Verilog version of UVM. Now this is a sample component class. Okay, so this is class sample component which is extending from UVM component. So here just we need to give in the parenthesis UVM component. Okay. And there is no need to write the factory registration macro, as we saw in case of system Verilog version of UVM. Why? Because this is because Python UVM automatically register all classes that are extended from UVM void in the factory. So no need to give the factory registration macro for UVM component, or if we are using any object component, for that also no need to give that registration macro, object registration macro. Okay, so this is what the build phase we are defining. So you can see the syntax for that, def build phase, and in the parenthesis just we have to give a keyword self. No need to write, as you can see this thing. Okay, in the build phase we are defining in the parenthesis, we are giving UVM phase and phase, so no need to give that kind of thing, just empty parenthesis in we have to give this self keyword. No need to give this UVM phase space phase kind of thing, and just super dot build phase empty parenthesis we are giving. Okay, no, here also no need to give phase in the parenthesis, and just we are printing info, and the info is self dot logger dot info, and in the parenthesis this is the build phase. Okay, so this is what the info message in Python version of UVM. The next phase is a connect phase, which is also we are defining def connect phase in the parenthesis self, and just we are printing a message, this is a connect phase. Same for end of elaboration phase. Okay. Then start of simulation phase. Then this is an interesting point, this is a run phase, and as I told you, run phase is like a coroutine here. Okay, for that we have to give async keyword, async def run phase, and we have to give self dot raise objection and drop objection. Just we are printing here also, this is a run phase. And then the extract phase, then the check phase, report phase, and the final phase. All phases are function based phases except this run phase. For that we have to give async keyword. Okay, so this means we must use async keyword. Okay, so that is as it is a task-based phase, we have to use this async keyword to define the run phase. Okay. And as in the phase, just need to give self, no need to give phase, UVM phase, space phase kind of organization. Okay. And there is no need to give end class over here. So in the next top level class is a test class. Okay, so we are just defining @pyuvm.test. This decorator is to notify cocotb that this is a test class. Okay. And we are defining class sample test in the parenthesis UVM test. So it is equivalent to this extend UVM test kind of thing. Okay. And in the build phase, just we are creating this this component, sample component in which we have defined all the phases. Okay. So you can see over here the syntax for create method is like self.comp. Okay. Here no need to define declare that component handler as we declared here. Okay. As we declared here, there is no need to do that in case of Python. Directly we can create self.cm equal to sample component. It is a class name in which we declared all the phases, and dot create. Okay, just create we have to write. No need to write this type id colon type id and colon kind of thing. And in the just here I am just giving cmp in single quote, and this is what a self. So this is what a simple thing. Okay, let me show you this code first. Okay, it just a sample thing in which we are printing the messages of all phases. So the main thing here, just we are understanding, we are trying to understand the differences between the UVM phases with respect to system Verilog version and the Python version. What are the different syntaxes? What are the different things in the phases? So as you can see, if we run the system Verilog version of UVM, then we will find that all the info messages from the sample component class, and the build phase we are printing, this is the build phase, then connect phase, end of elaboration, and so on till the final phase. Now let me show you the Python version of that. Here also we are just printing a messages. So just make command we have to give one, and you can see over here the messages. So this is from UVM test top CMP we are creating. Okay, as you can see here, which is a handler for this sample component class, and in which we have declared all the phases, build phase, connect phase, and all till the final phase. Okay, so this is what the thing we just try to understand here the syntax difference between Python version of UVM and system Verilog version of UVM for phases. Okay. So with this, I hope you have understood this phases concept with respect to Python version of UVM and system Verilog version of UVM, how to define all the phases. So this information will help you in the next video. So the next video is related to TLM, transaction level modeling, in which I will explain how the communication between producer and consumer, producer which is an initiator and the consumer which is a target component, how the communication between these two components is happening with the help of TLM. Okay. So in that, this phases concept will help you to create the things in that. Okay. So with this, I hope you have understood the difference in the syntaxes between two, Python version and system Verilog version of UVM. And also I hope you have enjoyed this video. So thanks for watching. Thank you.